In this video, I'll be discussing testing primality by factorizations. If n is a positive integer, such that 3 to the power of 2n plus 1 minus 2 to the power of 2n plus 1 minus 6 to the power of n is a composite number, find all possible values of n. To solve this problem, we first break down the exponents. This is going to be the simplest part. 3 to the power of 2n plus 1 minus 6 to the power of n. Use a different format. Minus 2 to the power of 2n plus 1. We can break it down into 3 times 3 to the power of n squared minus 2 to the power of n times 3 to the power of n minus 2 times 2 to the power of n squared. We have changed this into the format of the cross method. Now, we use the cross method to factorize. On one side, we can have 3 times 3 to the power of n and 3 to the power of n. This is going to be the left side. 2 to the power of 2n to the power of 2 can be split into 2 times 2 to the power of n and negative 2 to the power of n. We check that this works by the cross method. And after you cross multiply, you can get that it's going to equal to negative 6 to the power of n. So now we can factorize. This is going to equal to bracket 3 times parentheses 3 to the power of n plus 2 times parentheses to the power of n bracket multiplied by bracket parentheses 3 to the power of n minus parentheses 2 to the power of n. We can simplify to get that 3 to the power of n plus 1 plus 2 to the power of n plus 1 multiplied by 3 to the power of n minus 2 to the power of n. And now we just have to do some casework. We can get that the first case, when n equals to 1, this is going to be the only non-working case. Why? Well, notice that when n equals to 1, 3 to the power of 2n plus 1 minus 6 to the power of n minus 2 to the power of 2n plus 1. This is going to equal to 3 cubed minus 6 minus 2 cubed. 27 minus 6 minus 8, which equals to 13. And since 13 is prime, this means that n equals to 1 doesn't work. Since 3 to the power of 2n plus 1 minus 6 to the power of n minus 2 to the power of 2n plus 1 is composite. And now, the second case is when n is greater than 1. When n is greater than 1, 3 to the power of n minus 2 to the power of n is going to be greater than 0. And now, we get that this will be composite. Why? Because since 3 to the power of n minus 2 to the power of n is going to be greater than 1. Since 3 to the power of n plus 1 plus 2 to the power of n plus 1 is greater than 0, is greater than 1, and 3 to the power of n minus 2 to the power of n is greater than 1. So we can get that the product is composite because it can be written as the product of two expressions which are both greater than 1. So 3 to the power 2n plus 1 minus 2 to the power 2n plus 1 minus 6 to the power n is composite. So the answer is going to be when n is greater than 1, the number is going to be a composite. And that is how you solve this problem using factorization.